Hello, everybody, and thanks for having me. My pitch today shows a small insight into the current research at InnovationLab regarding hybrid electronics and reflow-soldered flex PCBs. Here we go. So the first development is our so-called active matrix from the Two Horizons projects together with the KIT. So the first development, the first two milestones have been reached so far. This is a general overview. So we're like right here now. So going from a matrix with the classical external PCB, as we all know it, to an active matrix with integrated electronics. So we printed here the multiplexer, decoder, converter, anything that was still external in this stage. We have now printed a digital circuit that goes alongside the active matrix. And then the next step will be printing the remaining components to, in the end, only have a thin silicone chip here. So we have all the electronics integrated. But why a sensor matrix in an active manner? We are pretty known for doing passive matrices. So why active? Because crosstalk can be eliminated by the matrix itself, which is still a problem for passive matrices. So due to the every pixel holds its own transistor in the active matrix. So only the touched pixel in the whole matrix is activated then, and the current leaves without interfering all other pixels, which is not the case in a passive matrix, which you see on the right. So we have the pixel made by columns and rows. And when I touch it in three places, the current that leaves mostly through the fourth pixel, still, which although it's not touched, and this is the so-called ghosting, which I can eliminate by having an active sensor matrix. Here you see some technical details and, of course, some pictures of the current stage. And here you see the second development within the project. It's the so-called hybrid electronics board, and it shows the integration of a classic PCB, which you can see here, right into the matrix, so between the sheets. And in the near future, it's the aim to completely print the traces and just add the SMDs in the end to get rid of the rigid parts and become more and more flexible. And flexible is the word, flex PCB, reflow soldering. This brings me to the last demonstrator. It's a temperature logger, or it aims to be a temperature logger developed in the Smarties 2 project, whereas our task as InnovationLab is to print the NFC antenna and also the circuitry, and in the end focus on the reflow soldering process. So a little description of the technology. It's done, or it shall be done, by sheet-to-sheet printing with some copper ink. And in the end then, as I said, it needs to be compatible with the reflow soldering process. And substrate will be FR4, PI, PET. And it all started actually by the general CAD design process that is the conventional process in PCB as well. But in the end, it shall be flexible. Here's some first results and also some challenges, as there always are. So due to the high copper dry thickness that is used or required for the NFC antenna design, that results in high ink spreading, though, when drying, because they run together and create shortcuts. So this ink spreading, and this is a problem in the IC for the IC landing patterns. And therefore, the idea was to print the antenna separately from the circuit, so we don't have that problem anymore. The antenna gets all the dry thickness it needs, and the circuit not. So also by searching for the right solder paste, this problem could be solved even more. Here you see the first print results, looks quite nice, and some first test results. And we're actually quite confident because the measured impedance quite nicely matches the simulations. And finally, in the end, you see some more results. So only the full circuit print, and then before reflow soldering when attaching the SMD pieces, and then in the end, out of the reflow oven on all 3 tested substrates. And in the end, we decided for FR4 because it worked best. So in the end, the Flex PCB is very bendable, and most important, it's working. And so we are very happy, and the project goes on now. But with that, I'm at the end of my talk. Thank you very much.
Thank you. Thank you so much, Meike.